Welcome back, dear children. Now we will move to our 7th chapter, sound. So this is a chapter from which most of the portions are removed by the ICSE board. Okay, so we need very few things from this chapter. So what I can say is, with while hearing the video, at that time itself you can write the lecture note. I need only lecture notes from this topic. Okay, because only very few things are needed. No need to copy the questions given at the back. I need just the lecture notes, and you have to study only those things what I am explaining here. Other things are removed from the syllabus by the board itself. Okay, even from 10th standard, from this chapter, same chapter sound is there. So what all things are removed there, same things are removed from here also. Okay, so shall we start? Okay, so how can you define sound? Sound is a form of energy. That is what first we can say, isn't it? A form of energy which produces the sensation of hearing can be called as sound. So sound is a form of energy which produces the sensation of hearing. Then what are the other things we know about sound? How is sound produced? Sound is produced by vibrations. Okay, so that's a very important point. Sound is produced by vibrations. When a body vibrates, due to these vibrations, sound is produced. Now the next thing is, sound requires a medium for its propagation. When we are considering light, it can even move through vacuum. But in the case of sound, a medium is needed. A solid, liquid or gaseous medium is needed for the propagation of or movement of sound. Now, sound moves in the form of waves. Okay, sound moves in the form of waves. So how can you define a wave? A wave is a disturbance which carries energy without the transfer of matter. So a wave, actually here the sound moves through a medium. When it moves through a medium, the sound will carry the energy, but it won't make or it won't transfer the molecules present in the matter. Okay, sound needs a medium for its movement. When it is moving through a medium, it will make the particles of the medium to vibrate, but it won't transfer those molecules to some other place. It just make the particles of the medium to vibrate, and it will be carrying the energy. Sound means it carries the sound energy. Okay, so sound moves in the form of a wave. A wave is a disturbance which carries energy without the transfer of matter. Even though it moves through a medium, it won't take the particles of the medium with it. Okay. So is it clear about the introduction part related to sound? Sound is a form of energy which produces the sensation of hearing. Then it is produced by vibrations. When a body vibrates, then only sound will be produced. It moves in the form of a wave. A wave is a disturbance that transfer energy without the movement of the matter. Okay. Now, next we will be considering about how the sound moves in a medium. Okay. So for that, I'm considering a tuning fork. Okay, so this is actually a tuning fork. A tuning fork consists of a stem with the two prongs. Okay, so this much bend won't be there. Almost like this we will consider. This will be a tuning fork, and this will be actually made up of steel. And when you hit this tuning fork on a rubber hammer, we'll be having something known as a rubber hammer. When this tuning fork is made to hit on a rubber hammer, the prongs of the tuning fork will vibrate. Okay, and as a result, sound will be produced. In the case of a tuning fork, the sound produced is very less, so it's not much audible to us. If it was from the school, means I could have shown you this. So now no other way to show a tuning fork. Okay. So what you have to remember, it is made up of metal. It consists of two arms called prongs, and this part is called the stem of the tuning fork. Now this, when you are hitting it on a rubber hammer, the prongs will start vibrating. So here I'll be considering this part. It vibrates means first it will move to this region, then it will come back, and again it will move to the next part. So like this it will be vibrating. So when this prong comes to this place, what happens here? What is present around this? We have air, isn't it? So when this prong comes to this side, vibrating means to and fro motion. So when it comes to this side, it makes the air molecules present here to compress. Air molecules spread in all the directions. So when this prong comes to this side, it compresses. Okay. So it compresses the air molecules present there. Then when it moves to the opposite side, anyway air molecules won't stay at a place, so this will move to this region. Okay. Then here again we will be having many air molecules. So when this prong move to the opposite side, what happens? The air molecules present here gets released. So here we will be getting like this. Here the molecules, air molecules are compressed. Here it gets released. So like this, the air molecules will move, or the sound gets transmitted in this form. The region where the air molecules gets compressed together, we will call it as compression. And where it gets released can be called as rarefaction. Okay. So once again I'll tell you, I have taken a tuning fork. When the tuning fork is hit on a rubber hammer, its prongs will start vibrating. Vibrating means to and fro motion. When this dotted lines represents the vibration. So when the prong of the tuning fork come to this side, it compresses. Our side like varumbam avadeyalla air molecules ne compress cheyum. Okay. So it compresses the air molecules present there. Then when it moves to the opposite side, what happens? The air molecules present there gets released. So the air molecules anyway, they won't stay at a particular place. It will move. That is why I have drawn the compression to the other side. So after compression, the air molecules gets released. There we will be getting rarefaction. If the air molecules are released, we will call it as rarefaction. So here, that when the tuning fork, when the prongs of the tuning forks vibrate, compressions, this process will be continuing. Number of compressions and rarefactions are formed. Okay. And here, when these waves, actually sound is moving, the movement to and fro motion of the prongs produces sound. Okay. So here, when these compressions and rarefactions move, actually sound energy is transmitted, and this makes the air is present in the medium. This makes the air molecules to vibrate. In this case, the vibration of the air molecules is in the same direction as that of the movement of the wave. Wave is moving like this. The particles of the medium also vibrate in the same order. Such a wave can be called as a longitudinal wave. Okay, it is known as a longitudinal wave. So what is a longitudinal wave? If the particles of a medium vibrate in the direction of propagation of the wave. Waves ഒരു directionൽ, particles of the mediumത്തിന്റെ vibrationും അതേ directionലാണെങ്കിൽ we will call it as a longitudinal wave. Okay. And in a longitudinal wave, the particles will always move in the form of compressions and rarefactions. And these longitudinal waves can move through solids, liquids as well as gases. So, once again, when we are considering sound, it moves through a medium. When the sound, it moves in the form of waves. When the waves are moving through a medium, it makes the particles of the medium also to vibrate. So, Here, the particles of the medium vibrate in the direction of propagation of the wave, and such waves are called longitudinal waves. Longitudinal waves always moves in the form of compressions and rarefactions. So, is it clear about the movement? We have one more type of wave, that is transverse wave. We are not discussing about that. It is not there in your textbook also. Okay, actually we are having two types, longitudinal and transverse, and we are discussing only about longitudinal waves. Only this is there for you to study. So is it clear? Longitudinal wave means the particles of the medium vibrate in the direction of propagation of the wave. It moves in the form of compressions and rarefactions. Now, next we will be considering about the characteristics of a wave. So, when you are considering a wave, what all terms we have to consider in the case of a wave? So, these are known as characteristics of a wave. Okay, so first we will consider how to draw a wave. Here, in order to represent a wave, normally we will show it. We will represent a wave using a displacement time graph. So, I am taking, let me draw it straight. We are considering a displacement time graph. Time will be taken along the x-axis and displacement will be taken along the y-axis. So, this is known as a displacement time graph. And I am going to draw a wave. This is a wave. Okay. So, displacement time graph for a wave. Now, here, time is taken along the x-axis. Displacement is taken along the y-axis. Okay. So, is it clear? Displacement time graph to represent a wave. Now, we are going to study in detail about the characteristics of a wave, and this is considered as the mean position. Okay, mean, and from there the particles will be moving up and down, and this is actually known as crest. This upper part is known as crest and this lower part is known as trough. One crest and one trough from here to here makes a single wave. That is the next thing what you have to remember. Okay, this part to this part makes a single wave. So a wave consists of one crest and one trough. Okay, so displacement time graph, wave, then this straight line, x-axis stands for the mean position. When it is not vibrating, the body will remain there. When it starts vibrating, it moves in the form of a wave. The upper part is called a crest and the lower one is called a trough. And one crest and one trough together makes a wave. Okay, now we will consider about the characteristics of a wave. First one is the amplitude. Okay, so what do you mean by an amplitude? Amplitude is the maximum displacement of the particles of the medium from its mean position. I told you this is the mean position. So when it gets disturbed, what happens? The particle will move up and down. So to what maximum height the particles can move, this height is known as amplitude. It is represented by the letter A. It is similar to our pendulum. In the case of pendulum, to what height it can reach, maximum height is considered as amplitude. Same thing here also, this is the mean position, to what height it can go. So the maximum displacement of the particles of the medium from its mean position. Mean position in etra height leke move chedu, that is considered as the amplitude. It is represented by the letter A. And here it is the maximum displacement. So what is the unit? It will be given in meter. Now, second one is the frequency. So what is frequency? Frequency is the number of waves produced in 1 second. Okay. How many waves are produced in 1 second? That can be called as frequency. It is represented by small letter f and its unit is hertz. Okay. HZ, hertz is the SI unit for frequency. So what is frequency? Number of waves produced in 1 second. Now the third one is time period. Time period is represented by capital T. It is the time taken to complete one wave. ഒരു wave complete ചെയ്യാൻ എത്ര time എടുത്തു? That is time period. So it is the time. So what will be the unit? Unit is second. Now the fourth one is wavelength. Wavelength is the length of a wave or distance between two consecutive crests. Length of a wave means how much will come as the length? This is the length of a wave. That is known as wavelength. It is represented by the letter lambda. So just listen how to draw lambda. This is lambda. Then here also it is length. So its unit is meter. These four things are known as the characteristics of a wave. What is the first one? Amplitude. The maximum displacement of the particles of the medium from its mean position can be called as amplitude, represented by small letter a. That means this is a. This or this can be called as a. Length ayadonda its unit is meter. Then number of waves produced in 1 second can be called as frequency. F. Its unit is hertz. Time taken to complete one wave. One wave means one crest and one trough. So that is known as time period. Its unit is second. Then the next one is wavelength. Wavelength is the length of a wave or the distance between two consecutive crests or troughs. That can be called as wavelength. It is read as lambda. Okay. Lambda, and its unit is meter. So is it clear? So these are called as the characteristics of a wave. These four are the characteristics of a wave. I am repeating the same thing because next is characteristics of sound. Okay. So these are the characteristics of a wave. Next we are going to learn about characteristics of sound. There are 3 characteristics for sound. Next, we are going to discuss about the characteristics of sound. Characteristics of sound. So, first one is pitch. Okay. Pitch means actually the shrillness of sound can be called as pitch. That is, if the frequency of sound is more number of waves are produced in 1 second. More number of waves are produced in 1 second, we will call it as high pitch. And if less number of waves are produced, we will call it as low pitch. So pitch of a sound means actually it is the shrillness. We will use the word shrillness of sound. Okay. Shrillness of sound is known as pitch. Pitch means it is actually pitch is a sensation. Okay. The measurable quantity of pitch is frequency. Pitch depends on the frequency. This is what we have to remember. We are discussing about the characteristics of sound. First one is pitch. Pitch is also known as shrillness, pitch or shrillness. So this is actually a sensation. Okay, pitch means it is a sensation. Here pitch depends on the number of waves produced. Pitch depends on the number of waves produced. If more number of waves are there, we will call it as high pitch. And if there are less number of waves, we will call it as low pitch. Then it depends on the frequency. Pitch is directly proportional to frequency because frequency is the number of waves produced in a second. If more waves are produced, pitch will be high. If less waves are produced, pitch will be low. Okay, so is it clear about pitch? Many examples are there. So it is not there. Examples are removed from our syllabus. No need to consider the examples. What you have to remember? about just the characteristics and what does it depend. Okay. So pitch depends on the number of waves produced. Number of waves produced means that is frequency. Pitch depends on the frequency. If more number of waves are produced, high pitch. Less number of waves are produced, low pitch. Okay. So keep only this in your mind. Now, the second one is loudness. Loudness is also a sensation. If by hearing a sound, I will feel it as a loud sound, but for another person, it is not necessary that it will be loud. So loudness is also a sensation. Loudness mainly depends on amplitude. Okay, so that is what we have to remember. Loudness depends on amplitude. Do you remember what is amplitude? Amplitude is the height of the wave. So if amplitude is more, the sound will be loud. If the amplitude is less, the sound will be less. So this is the main factor on which loudness of a sound depends. Again, three more things we can say that also you have to note. Surface area. If surface area is more, the sound will be more. If amplitude is high, loudness will be more. If surface area is more, then also loudness will be more. Then the third one is distance between the source and the listener. If the distance between the source and the listener increases, loudness decreases. So I am standing here and producing sound. For a person standing in some other room, what about the loudness? The loudness which he feel will be less. But for a person standing in the same room, the loudness will be more. So if the distance between the source and the listener increases, loudness will decrease. Okay. So actually, these three are the main factors, and one more thing is there in your book, that is about the sensitivity of the ear. So if our ear is more sensitive, we will feel more loudness. Okay, so sensitivity of the ear. These are the four factors on which loudness depends. So actually only till this is mentioned in your syllabus, but when we speak about characteristics of sound, one more factor is there. Okay, so I'm just saying what it is. Please consider that also, because after telling two and when you move to higher classes, you will learn about the third one. You will be confused. So it's better just to study the name. Okay, third factor is quality or timbre. Okay, be careful with the spelling. It is not B-E-R-T-I-M-B-R-E. Quality or timbre. Quality or timbre is the third factor, and it actually depends on the wave pattern. We have different wave patterns. Here it comes mainly in the case of musical instruments. If you are playing veena and violin, and in both, if the pitch and loudness are same, then also the sound or the music produced by veena and violin will be different. Even though the pitch and loudness are same, the sound heard from a veena and a violin will be different. The reason is its quality or timbre. Quality or timbre depends on the wave pattern. For one instrument, it will be like this. For another instrument, the wave pattern will be this. So different wave patterns will be produced by different instruments. Okay, so is it clear? Once again, we were discussing about the characteristics of sound. There are three characteristics for sound. First one is pitch. Pitch depends on frequency. That is how many waves are produced. If more number of waves are produced, high pitch. If less number of waves are produced, low pitch. Then pitch is also known as the shrillness of sound. Then the second one is loudness. Loudness actually depends on the amplitude. If amplitude is high, loudness will be more. Then if the surface area is high, then also loudness will be more. If the distance between the source and the listener increases, loudness decreases. If the sensitivity of the ear is more, then also loudness will be more. Now the third one is the quality or timbre. Quality or timbre actually depends on what? Wave pattern. Okay, it depends on the wave pattern. So we are having many examples given in the textbook that is removed by the board from the syllabus. So only these many things you have to study from this chapter. Other things are removed. Okay, so is it clear? And one more thing, the unit used to represent loudness is dB, decibel. Okay, that also you should remember. Loudness is measured using a unit called a decibel. dB or decibel. Okay, so is it clear? So as I said earlier, I need only lecture notes from this topic and you have to study only these things. That is introduction part. What is a wave? How a wave moves. Then about the wave pattern, displacement time graph to represent a wave, characteristics of a wave as well as characteristics of sound. Characteristics of wave means amplitude, frequency, time period and the wavelength. Characteristics of sound means pitch, loudness and quality or timbre. And one more thing I have to say, we learned about time period and frequency. As we learned in the case of pendulum, there is a relation connecting these two. What is that? Time period is equal to reciprocal of frequency. T is equal to 1 by F. So keep this in mind. Okay, T equal to 1 by F. So please go through this chapter, prepare lecture notes, study this. It's a very, very simple thing. Okay, so thank you children.